Hello and welcome. This is Mr. E and this is lesson 2, solving one-step multiplication, division, inequalities, and specifically talking about negative coefficients because it makes a difference. It's a pretty important lesson here. Easy to make mistakes, something you'll use a lot going forward, but if you just know how it works, it's no problem. All right, so again, we're still looking for the set of values that makes an inequality true, or the set of solutions. Let's get started. All right, so inequalities we know have an infinite number of solutions. To solve a one-step inequality, we use inverse operations, same as in one-step equations. However, when the coefficient is negative, we have to remember to reverse the inequality sign. Let me show you an example why that's true. All right, so we're going to find the set of solutions to a negative 3 times some number c is greater than or equal to 15. Now, we've done this with positive, but negative makes a difference. Positive coefficients. So negative 3 times some number c is greater than or equal to 15. Negative 3 times some number c greater than or equal to 15. I'm going to divide both sides by negative 3. Now, I'm not going to change it. I know I set it up here, but I'm not going to change it. I want to show you something. So c is greater than negative 5. But is that true? So let's go ahead and check that. We're saying that the solution to this equation is any number greater than negative 5. Well, if I check that, I pick a number like 0. 0 is greater than negative 5. And I replace or evaluate negative 3 times c. And I say that c is equal to 0. If I evaluate the inequality, it's not true. 0 is not greater than 15. So something's wrong. This is not the solution. How do I find the solution? Well, I have to, because I have a negative coefficient, it's basically saying the opposite of c is greater than or equal to negative 15. So I take the opposite of greater than or equal to, which is less than or equal to. Trust me, it works. So negative 3 times some number c is greater than or equal to 15. I'm dividing by a negative 3. I have to invert or switch my inequality sign. So now my answer is any number less than negative 5 or less than or equal to negative 5 should make this true. My solution should be any number less than or equal to negative 5, not greater than or equal to negative 5, because that's the inverse. Let me check that. I pick a number less than negative 5, which is negative 6, for example. So negative 3 times negative 6 is 18. It's true. 18 is greater than 15. So don't have to really know why, but understand by this example that if you don't change the inequality when you have a negative coefficient, you're not going to get the right solution set. Let's do a few. So you have negative 3 times some number x is greater than 9. I have a negative coefficient. I'm going to divide both sides by negative 3. And when I do that, I have to change my inequality. So my answer is anything less than but not equal to negative 3. Let's check that. Let's just try negative 4. Let's evaluate negative 3 times x when x is negative 4. You have negative 3 times negative 4, which is 12, and 12 is indeed greater than 9. So it is correct. Got time for one more here. Negative 3 times some number x is less than 9. Again, I have a negative coefficient. So when I divide both sides by negative 3, I have to change or invert, if you will, my inequality. So my answer here is any number greater than but not equal to negative 3. We'll check that real quick before we stop. So I have negative 3x. I'm going to let x equal, let's say, 2. Negative 3 times 2 is negative 6. And negative 6 is less than 9. So it does check. All right, very important concept. So we're going to stop right here. When we come back, we're going to practice some more. Hopefully you'll finish those problems before I come back, and you'll just see what the answers are. Talk to you soon.